Hi there. In section 8.1 through section 8.3, we will be looking at unit conversions. We are going to focus on three main unit conversions. We are going to be talking about converting things in terms of length, or we could say distance. We will be converting weights, and we will also be converting capacities. We know that length tells us how far or how long something is. Weight tells us how much something weighs or how much the earth is pulling on an object, whereas capacity is a liquid substance of how much it holds inside of it. Those are the three we will focus on. Before we get to those, we need to talk about what a measurement is. In Objective A, we're converting measurements in the U.S. customary system. A measurement includes a number and a unit. So for example, 9 feet is a measurement. 23 pounds is a measurement. 1 2/3 cups is a measurement. Measurements include a number and a unit. It's very important that everything we do within 8.1 to 8.3, we always include units with our answers. So the standard U.S. customary units of length, our distance, are going to be, and we can see them in the chart below here, inches, feet, yard, mile. Those are the ones we will focus on in this class. So we have our inches, feet, yards, and miles. Those are going to be how we're going to measure a length or a distance. Weights. We're going to talk about ounces, pounds, and lastly, tons. Those measure how much something weighs. And in the last one, we have capacity. Capacity is how much we can put into something. Now here we also have, you can notice in the chart, fluid ounces. Be careful not to get ounces and fluid ounces mixed up. Two different things. Ounces tell us how much something weighs. Fluid ounces tells us how much liquid something can hold. So here we have fluid ounces. We also have cups. We have pints. We have quarts. And lastly, we have gallons. Those are all we call capacity. Now, everything we're focusing on here are going to be in the U.S. customary system. We will not be looking at any metric measurements. These charts that you see here, the conversion charts, those will be given to you on the exam, so you do not have to memorize those. All right, let's see how we're going to use these things. A conversion rate is used to change from one unit to another. So we're going to be using a conversion rate in every single one of our problems. For instance, because 3 feet equals 1 yard, the conversion rates are 3 feet to 1 yard and 1 yard to 3 feet. You can see here, these are both equivalent to 1. That's because whatever is present in the numerator is the same, in this case, length as what's in the denominator. 3 feet is the same as 1 yard. And anytime you divide something by itself, it's equal to 1. We have to pay close attention to the unit that's being given to us to know which of these we have to use. So let's go ahead and try out an example. We're going to actually look at example 1 using letter B first. And this is answer using mixed numbers if necessary. So letter B says convert 8 yards to feet. So we always want to start with the measurement that is being given to us. So we start with 8 yards. And then we're always going to put a 1 underneath that. That's the first step, no matter what the problem looks like. And then we have to multiply this by a conversion rate. So again, one of these two things here. So let's use a different color for that just so we can see what we're doing. We'll use the conversion rates in red. And it's going to be a fraction. Now, this is why I wanted to go to B, because we're going to use either this one or this one, and we need to figure out which one to use. The idea here is we need to get rid of the unit of yards because we want to convert it to feet. And in order for this to cancel out, we need yards over here in a denominator because as we know from previous sections, things will simplify out if we have one in the numerator and one in the denominator. So we need to have a yard in the denominator. That tells us that we need to use this conversion rate because we have yard in the denominator and we need to convert it to feet, so we write that in the numerator. Now, I said we're going to use this one, but let's figure out how we would know where to put the 3 and the 1. Is it 3 feet to 1 yard, or is it 1 foot to 3 yards? So we have to think, right? It's 3 feet in 1 yard. Make sure you put your numbers next to the appropriate unit. 3 feet is equal to 1 yard. Now we know that the yards will cancel, and we're just left with feet. Now, how do we multiply fractions? Right, we go straight across. So we have 8 times 3 over 1 times 1. And then we have to simplify that. 8 times 3 is 24. 1 times 1 is 1. 24 divided by 1 is 1. So then we have 24, and then we bring over our unit of feet. So if you have 8 yards, that's the same as 24 feet. Okay, let's try convert 84 inches. Let's go back to letter A. So we want to convert 84 inches, so we put that over 1. Now we need to use a conversion rate. If you need to, flip back to the front page, but we know we have to get rid of this inches right here. So where do we put inches at over here? Right, in the denominator because we needed to simplify out. So we put inches over here in the denominator, and then we're converting to feet, so that goes in the numerator. So now we need to think of what's the conversion rate between inches and feet. Well, we know a foot is bigger, so 1 foot has how many inches? Right, 1 foot is 12 inches. Here the inches cancel, which is what we need to happen. Now we multiply our numerators. 84 times 1 is 84. 1 times 12 is 12. And then we want to continue to simplify this. So if we type 84 divided by 12 in our calculator, we're getting an answer of 7, and it would be 7 feet because that's the unit that we are left with. Okay, let's look at this last one here. We want to convert 7 pounds, so we start by putting 7 pounds over 1. Make sure you don't end up looking at that as 71, and then we have to multiply it by a conversion rate. Well, since pound is in the numerator, we know pound has to go into the denominator, and we are converting it to ounces. So now, what's the conversion between pounds and ounces? If you need to, flip back to your chart. Right, we know 1 pound is the same as 16 ounces. So then we multiply or double check that our units cancel, so pound for pound, and then we multiply straight across. So we have 7 times 16, which is going to give us 112, and then the denominator would just be 1 times 1, which is 1. So we'd have 112, and we can just say ounces. So there, we didn't have to change any to mixed numbers. If we had to divide something out, so for example, like this first one, how we had to divide by something other than a 1, if this didn't divide into an integer, maybe meaning if we got a decimal, we'd have to leave it as a mixed number. Now, I'm going to let you, all right, let's actually go through all of these too, just so we can make sure we really understand, and then I'll let you try the bottom problems out. So convert 9,000 pounds to tons. Let's actually have you try to at least set this one up on your own. When you're done, unpause the video. Okay, so looking at this problem, just setting it up, we start with the 9,000 pounds, put it over a 1, and then we have our conversion rate. Since pound is in the numerator, we have to write the pound in the denominator, and we're converting it to a ton. Then we double check on the conversion rate. We see that 1 ton, so we put the 1 next to the ton, is equal to 2,000 pounds. And we can see that the pounds do cancel, which is what we want. Now we multiply straight across. So when we do this, 9,000 times 1 is 9,000. 1 times 2,000 is 2,000. When we divide this on the calculator, we're getting 4.5. We know 0.5 is equal to a half. If you didn't know what the fraction was, type in your calculator 0.5, math, enter, enter, and that'll convert it to a fraction. So we know this is the same as 4.5, and the unit is, I'm running out of room, tons. That says tons over there. 4.5 tons. Okay, letter E. Go ahead and try this one. Let's have you guys try this one start to finish. Okay, looking at this problem, 36 fluid ounces over 1. And then we have to convert it to cups. Since fluid ounces in the numerator here, fluid ounces needs to be in the denominator here, and we're converting to cups. Double check your conversions. We know that 8 fluid ounces, so the 8 needs to go next to the fluid ounces for 1 cup. 36 times 1 is 36. 1 times 8 is 8. Fluid ounces cancel, so we're left with cups. 36 divided by 8 is 4.5, but we leave it as 4.5 cups. Good. Okay, now letter F. You notice that right off the bat we have a fraction. The easiest way to work with fractions, just like we talked about in the first section of this unit, is convert that fraction to a decimal. So take 1 divided by 4 if you don't know what it is, and it's 0.25. So we're going to write this as 2.25 gallons over 1. So if you see a fraction, divide it first. That'll make it easier. Now we can set up that conversion. Okay, now from here, I want you to pause the video and finish this problem. Okay, so we have gallons here, so we put gallons in the denominator, and we're converting it to quarts. Double check your conversion. You see that there's 4 quarts to 1 gallon. So the 4 has to go next to the quart, the 1 has to go next to the gallon. Always start with the units first. That way you know where they go. And then you just match up the numbers and put it next to the correct unit. Gallons simplify, so we're left with 2.25 times 4 and then 1 times 1. Well, 2.25 times 4 is 9, 1 times 1 is 1, so it's just going to be 9 quarts. Notice how each of these problems, whether they're working with measurements of distance, weight, or capacity, we work through these problems the same way no matter what the units are. And this holds true for any conversion problem you ever have to complete. You can use this process no matter what it is. Okay, so now let's have you try the problems at the bottom. Let's have you start with A, B, and C. When you're finished with A, B, and C, unpause the video and check your answers on those. Once you are good with A, B, and C, then go back and work through D, E, and F. So pause the video and go ahead. Okay. A, 5.5 gallons. B, 1.5 feet. C, 4 pounds. This would be the work that I would need to see. I need to see that you're setting up the correct conversion rate for each problem. I know sometimes we can just do these operation in our calculator, but you want to make sure you show me what you are doing. How are you getting those answers? Also, always include units as you work through the problem. That way you can always make sure you have things lined up appropriately. Okay, once you feel okay about those, go ahead and try D, E, and F. Okay. Check your answers and your work with those 3 problems. Once you're good with those, go ahead and go on to the next page. Okay, now what we're looking at with objective B is to perform arithmetic operations with measurements. So what we're going to do is take a measurement like 50 inches and convert it to feet and inches. So rather than just converting it to feet and maybe having a mixed number in there, we want to know how many feet with how many inches are left over. So that means we have to divide this. So we will start with the number that is being given. So we have to take 50 and we need to divide 12 into it. Now, the reason why we choose 50 and 12, 50 is because that's what was given to us, and we are using 12 because that's what the conversion is between inches and feet. And that's what this note says, because 12 inches equals 1 foot, we divide 50 by 12. We want to know how many 12s go into 50. So if we use our calculator, we know that 12 will go into 50 4 whole times. And then when we just do this longhand division, we know 12 times 4 is 48. And then we subtract 50 minus 48 is 2. That means that 4 whole feet go into 50, and then we have 2 inches left over. your remainder will go in this spot here. And then this number here is how many total feet. So it's saying 50 inches is the same as 4 whole feet with 2 inches left over. All right, let's look at 2 together and then we'll let you try the last 4. So the next one, we want to convert 31 feet into yards and feet. So we start with the number that was given to us as 31, and we have to divide something into it. And since our conversion, we're looking at yards to feet, well, how many feet are in a yard? Right, that's 3. So we have to divide 3 into 31. Well, 3 goes into 3 once, 1 times 3. We're just doing the longhand division there. 3 goes into 1 0 times, so 0 times 3 is 0. We subtract, we're left with 1. So that means if you have 31 feet, that's the same as 10 yards with 1 foot left over. All right, let's try the next one. Convert 9 pints into quarts and pints. So here we start with the 9, and we have to divide something into it. So we have to convert quarts and pints. Well, if you need to, look back. Okay, we know the conversion is 2 pints to 1 quart. That means we need to divide 2. You're always going to have you're going to have a number that's 1 and then another number. You always want to divide by the non-1 number. So 2 goes into 9. We know 2 goes into 9 4 times. 4 times 2 is 8. We subtract, we get 1. So that means if you have 9 pints, that's the same as 4 quarts with 1 pint left over. Okay, so now what I'd like you to do is try the 4 year term problems. We'll start the same way. We'll have you start with A and B and check your answers on those. And once you're good with those, go ahead and try C and D. Okay, for your turn A, you should get 5 pounds, 5 ounces. We have to divide 16 into 85 because there's 16 ounces in a pound. And then convert 100 inches, that would be 8 feet, 4 inches. We can divide 12 into. Again, we know what number to choose on the outside by whatever the conversion rate is between the 2 units. Once you're good with those, try C and D. Okay, for letter C, 14 quarts is 3 gallons, 2 quarts. 9,000 pounds is 4 tons, 1,000 pounds left over. Okay, objective C is just doing the same thing we were doing on the first page, but now we are looking at application problems. So I'll do letter A with you, and then I'll let you try B and C. A, 32 yards of material were used for making pleated draperies. How many feet of material were used? So first thing you always want to identify is what is the conversion you have to look at. We have to take yards and convert it to feet. So we have to go from yards to feet. That's what we're looking at. Same way, we start at 32 yards. So we're going to start with 32 yards, put it over 1. And we have to multiply it by a conversion rate. If yards is in the numerator, we need to put yards in the denominator. And we are going from yards to feet. Now we know that there are 3 feet to 1 yard. So it's 3 feet. So we put the 3 next to the feet, the 1 next to the yard. And then we multiply. Well, make sure your units cancel, yards with yards. Good. 1 in the numerator, 1 in the denominator. And then we have to take 32 times 3, which is 96. 1 times 1 is 1, so we don't do anything with that. And then we're left with 96 feet. So again, we're using the same process that we used on the previous page. So go ahead and pause the video and try B and C. Okay, and last but not least here. A cafeteria sold 124 cartons of milk in a day. Each carton contained 1 cup. So that tells us we have 124 cups of milk. How many pints? So we have to go from cups to pints. And then saying how many were sold that day. So we take 124 cups, and we know it's 1 pint and 2 cups. The cups cancel. We have 124 times 1, and then 1 times 2. This would be 124 over 2, so we have to divide it and get 62 pints. And the next one, a Tesla Model X weighs 5,307 pounds. Find the weight in tons. So we're going from pounds to tons. So we start with 5,307 pounds over 1, set up our conversion rate, and then we have to do 5,307 divided by 2,000 to get 2.6535, round to the nearest tenth for 2.7 tons. Now, Oftentimes the question is, how do we know when to multiply the numbers or divide? And that just depends on how the problem's set up. For example, in A, you can see that the numbers that are not 1 are both in the numerator. That tells you to multiply. When you set up your conversion rate, if your number that's not 1 is in a denominator, that's when you have to divide. Okay, that's all we have for this section. Make sure you give it enough time for the homework because it does take a little while to work through. All right, and we will see you next time.